Alright, dear children, now we move to the next problem, that is problem number 5. Okay, so in this YouTube video we basically solve two numerical, that is problem number 5 and problem number 6. So with these two numericals, your chapter heat transfer get completed. Okay, now problem number 5 is based on the expression of coefficient of thermal conductivity. Okay, so problem says that the cross-sectional area of a brick. So there is a brick whose cross-section area of a brick wall is 2 meters square. So what is the cross-section area of brick wall? 2 meters square. So let me start doing the solution of this question. Okay, so for brick wall, this is for brick wall. Okay, the cross-section area is marked by letter A, that is 2.0 meters square. Okay, and its thickness is 12 centimeter. Now thickness is actually the distance between the two ends of the wall. Okay, and that thickness is marked by letter L, that is 12 centimeter. So I change centimeter into meter. So 12 into 10 to the minus 2 meter. So children, remember this part, to convert from centimeter to meter, multiply by 10 to the minus 2. Okay, and okay, then after question say that if the difference of temperature between the two sides of the wall is 24 degrees Celsius, the temperature difference means definitely theta 1 minus theta 2. So theta 1 and theta 2 is the difference in temperature. This is the difference in temperature between two sides of the wall. That is difference in what? Temperature. So what is the difference in temperature between two sides of the wall? That is 24 degrees Celsius. So I write in degrees Celsius only. Okay, now calculate the amount of heat flowing through the wall in 1 hour. So time in which the heat is flowing through the wall is how much? 1 hour. So I don't know 1 hour. So in 1 hour, how much time, how much amount of heat that flows through the cross section of the wall? That we need to find out. But children, we convert this 1 hour into second. So I multiply by 60 into 60. Because we have to write this time in what second? Which is nothing but 3600 second. So what is the time in which the heat is flowing through the two sides of the wall? That is 3600 second. Okay, now what we need to calculate the amount of heat flowing. But for this question, the thermal conductivity of brick is how much? Thermal conductivity is basically expressed by letter K, and the thermal conductivity of brick is how much? 0.13 joule per second per meter per degree Celsius. So this is the thermal conductivity of a brick. Now what we need to find? The amount of heat flowing through the wall. So that I write down as Q. So I consider Q be the what? Q be the amount of what? Okay, amount of heat flowing. The amount of heat flowing. Okay, amount of heat flowing through the wall. So the amount of heat flowing through the wall is Q. Then there is a formula you have learned already, and the formula is Q equals to Ka theta 1 minus theta 2 T by what? L. So this is the formula we have already derived. Okay, with this expression we can even measure the coefficient of thermal conductivity. But children, in this question K is given. K means coefficient of thermal conductivity is known. So we can calculate this Q directly by using this formula. Because we know everything. We know K, we know A, we know theta 1 minus theta 2, we know time, and we know the thickness or the length. Okay, so let's substitute the value. K means 0.13 into area is 2.0 meters square, means 2 only. Okay, into the theta 1 minus theta 2 is 24 degrees Celsius. I write down 24 only. And the time which is given is 3600. Okay, divided by L, the length, which is how much? 12 into 10 to the minus 2. So now we can simplify this. Okay, so let me divide. 12 1s are 12, 12 2s are 24. Now 0.13, so it will 0.13 into 2 2s are 4 into 36. Okay, let me write 3600 as 36 into 100, but 100 means 10 to the power 2. Now 10 to the power minus 2, if I take in a numerator, is 10 to the power 2. Okay. Now 0.13 into 4 into 36, we can multiply. Okay children, if you multiply 0.13 into 4 into 36 with the help of calculator, you get approximately 18.72 into 10 to the power 2, 10 to the power 2 means 10 to the power 4. So your heat, amount of heat that is flowing through the wall, side of the wall, okay, wall of the brick in 1 hour is 18.72 into 10 to the 4. The unit is joule. But children, this answer I write in single digit because this is in 10 digit, so I write in single digit. So there is a positive power, and this decimal I shift one decimal to left. If I shift one decimal to left, it will be 1.872. Now if there is a positive power and if you shift to one decimal place left, your power increases by 1. Then 4 becomes 5. So it is joule. So finally, Q, the amount of heat flowing through the wall, side of the wall of a brick in 1 hour is 1.872 into 10 to the power 5 joule. So this is one of the problem based on the coefficient of thermal conductivity. And this is problem number 5. Now I'll be doing last numerical problem, that is problem number 6. And children, problem number 6 says that a 10 centimeter thick slab of surface area 0.36 meter square is placed on a hot surface at a constant temperature of 100 degrees Celsius. Means, let me just draw with the draw the diagram to make you understand. This is the hot surface. Consider this is a hot surface. Okay, and this hot surface is at temperature how much? 0 to 100 degrees Celsius, and over this surface there is a slab which is placed. There is a slab which is placed. Okay, and this slab is of thickness that is 10 centimeter. Okay, so when this slab placed on the hot surface at constant temperature 100 degrees Celsius, okay, then definitely this end of the slab absorb the heat. Okay, this surface of the end of the slab absorb the heat, same amount of heat, that is 100 degrees, absorb the amount of heat at temperature 100 degrees Celsius. Okay, so that what happened? A block which is placed, the block of ice, is placed at 0 degrees Celsius on the upper surface of the slab. So this is the slab. So children, this is the slab, and on the upper surface there is a block of ice which is placed. So this is a what? Block of ice. This is ice which is placed, and this ice which is basically at how much degrees Celsius? 0 degrees Celsius. Okay, now definitely at this surface the temperature is 0 degrees Celsius, at this surface the temperature is 100 degrees Celsius. So there is a difference in temperature between the two ends of the slab of thickness 10 centimeter. So what happened? Definitely there is a heat transport takes place from hot surface to the surface, upper surface. Okay, the heat which flows in such a way so that this ice which is placed on the upper surface absorb all the amount of heat. Okay, absorb all the amount of heat, and after absorbing all the amount of heat in half an hour, this 2.4 kg of ice is completely what? Melt. Completely what? Melt. So in this question what you need to calculate? Find the coefficient of thermal conductivity of the materials of the slab, so that the latent heat of fusion of ice is 3.35 into 10⁵ joule per kg. So this is an interesting question. Okay, so let's do the solution of this question. Now this question is also based on the expression of coefficient of thermal conductivity, but your slab thickness is given 10 centimeter. So the thickness, this is for slab. There is a slab, and for this slab your thickness which is given, and we mark by letter what? L. So L is the symbol we use for thickness, and that is 10 centimeter. So 10 centimeter can be written as 0.1 meter. So what is the thickness of the slab? 0.1 meter. And children, when you place this slab on this hot surface, heat flows in this direction. So this arrow means the heat flow in this direction, which is perpendicular to the surface of certain area. And what is the slab of surface area? Surface area is given A, which is 0.36 meter square. So this surface area is 0.36 meter square. Okay, and this slab which is placed on the hot surface at temperature what? 100 degrees Celsius. Now this 100 degrees Celsius is actually θ1, the temperature. The temperature at a higher temperature, that means θ1. So θ1 is 100 degrees Celsius. Now there is a block of ice which is placed on the upper surface at temperature 0 degrees Celsius, and this temperature will be θ2, that is 0 degrees Celsius. So definitely there is a difference in temperature. So I write down difference in temperature. So your difference in what? Temperature. Okay, and difference in temperature is given by theta 1 minus what? Theta 2. And theta 1 minus theta 2 means 100 minus 0 means simply what? 100 degrees Celsius. Okay. Now it is placed on the upper surface. Now in half an hour time means time is also given t, that is half an hour. Now half an hour time means 30 minutes. 30 minutes. Okay. Which means it is, if you convert into second, it is 1800 second. Okay. Now in half an hour time, what is the mass? 2.4 kg of mass melt, means your mass of ice, a block of ice is 2.4 kg. Okay. Now find the coefficient thermal conductivity of the materials of the slab. So the latent heat of fusion of ice is 3.35 into 10 power 5 joule per kg. So means L is actually symbolized as latent heat of fusion of ice, which is 3.35 into 10 power 5 joule per kg. Now what we need to calculate? The coefficient thermal conductivity. So I write down, let K be the what? Be the coefficient of what? Thermal conductivity. The coefficient of thermal conductivity. Thermal conductivity. Conductivity of the materials of the slab. Now in order to calculate the coefficient of thermal conductivity, okay, now first of all we calculate the amount of heat, okay, that flows from one end of the slab to other end of the slab in time 30 minutes. And this heat which flows basically from what? Hot surface to the surface, upper surface, okay, and when it flows, okay, definitely the heat which is absorbed by this ice, whatever heat which flows from the hot surface, that is the heat which is absorbed by this slab, okay, without change in what? Temperature. So the amount of heat absorbed by this ice to melt, completely melt into water, okay, completely melt, so without any rise in temperature, is given, expressed and given and expressed in terms of what is latent heat, and the formula is Q equals to M into L. Children, you have learned one of the chapter in class 10, calorimetry. So in that chapter you have learned the amount of heat absorbed by a substance, okay, can also be expressed in terms of latent heat, and this is called specific latent heat, that is given by Q equals to M into L. So let me first calculate this heat. Okay, so M, mass is 2.4, L, the latent heat is 3.35 into 10 power 5. Okay, now we can calculate the value. So if you calculate the value, so if you multiply 2.4 into 3.35, so we get approximately 8.04. So look at it, 8.04 into the power is 10 to the power 5 joule. So this is the heat that flows from one end to other end. Now actually we need to find the what? Coefficient of thermal conductivity. And in order to calculate the coefficient of thermal conductivity, there is a formula you have learned already, that Q equals to Ka theta 1 minus theta 2 T by what? L. So this is the formula that measures the amount of heat flows in terms of coefficient of thermal conductivity. Okay, so now from this formula I can substitute the value. So Q, as we have calculated, that is 8.04 into 10 power 5. K, that we need to calculate, into area. So area is given. Area is how much? 0.36. Now temperature difference, theta 1 minus theta 2, that we have already calculated, is 100 degrees Celsius. The time in which the heat is flowing is 1800 second. By the length or the thickness of the slab is how much? 0.1. So if we cross multiply, I'll make K as the subject. If I make K as the subject, we can cross multiply. If there is no number 1, consider 1. So if I make K as the subject, directly I can write down 8.04 into 10 to the power 5 into 0.1 divided by this quantity will go in the denominator, which is 0.36 into 100 into 1800. Okay, now from here we can do the calculation. Okay, now from here let me just do the calculation. It is 8.04 into 10 to the power 5 into I write down this is 1 by 10 in the denominator. Now 0.36 into 100 means 36 into 1800. I write down 1800, but there are already 3 zeros in the denominator. So let me just do the calculate. 8.04 into 10 to the power 5 by 36 into 18 into, now 30 means 10 to the power 3. Now this 10 to the power 3 I'll take in the numerator. So I write down 8.04 into 10 to the power 5 minus 3. So if you follow the exponent, 5 minus 3 by 36 into 18. Okay. Now this quantity, so it is 8.04 into 10 to the power 2 by 36 into 18. Okay. Now 8.04 into 10 to the power 2 means 100. If you multiply, is 804 by 36 into 18. Now children, you can multiply 36 into 18, and whatever you get, if you divide to 804, you get the value approximately 1.24. So you can do with the help of calculators, check it out. So you get 1.24 approximately in 2 decimal place, and this is the value of K. And the unit which we write is joule per second, okay, per meter and per degree Celsius. So do the calculation, divide, multiply these two and divide to 804, you get 1.24, and the unit, as I said, that is joule per second per meter per degree Celsius. So this is the calculation of coefficient of thermal conductivity. So with this numerical problem, the chapter heat transfer is completed. Now we will be moving to next important chapter under unit number 8, that is thermodynamics. Okay, and that we do in the next YouTube video. Thank you so much.